Welcome everyone. In this video lecture, we will solve a GATE 2007 question which is based on a op-amp and a diode connected numerical. So in this question, a figure is given which consists of a op-amp and a resistance and a diode, and we have to assume that the diode current follows the equation I equals to Is e to the power V by Vt, general diode equation, and for given Vi 2 volt, the output voltage is V01, and for Vi input voltage when 4 volt, the output voltage V02. So we have to find the relationship between V01 and V02, and these are the options given here. A, B, C, and D are the four options. So we have to solve this problem. Diode op amp based numerical basically. So in this question we can easily say it looks like a inverting amplifier. So in this case, this current is say some current I, and this current will be also I, and this voltage across this point will be 0 volt. Due to virtual ground concept, this voltage will be 0 volt. So the same current will flow in the 2 kilo ohm resistance and across the diode. Same current will flow. Okay. So once again I am writing the given thing is our I equals to Is saturation current exp V by input V by Vt, and also given when Vi equals to 2 volt, the V0 value will be V01, and one more relationship is given. Vi when 4 volt, V0 equals to V0 2. So we have to find the relationship between V01 and V02. Okay, so now we have to take care of this figure first. So what we can say, now when we are considering for Vi 2 volt, V0 equals to V01. So the current I in the circuit is nothing but simply we can write it Vi minus 0 by 2, which is our I. Okay, I am writing this I. Okay, this I current will flow. The same current will go in the diode. So the diode current is nothing but simply what we can write the saturation current Is exp this V. So this V is nothing but simply 0 minus V0. 0 minus V0 divided by Vt. Basically, this one is the voltage across this diode. Vd we can say, if say this one is Vd, so the voltage across this point should be 0 minus V0. So I am writing 0 minus V0 Vt. Is this equation is clear? Vi minus 0 by 2 Is exp 0 minus V0 by Vt. So say this one is our equation number 1. Now we can simply write this as a Vi by 2 Is exp minus V0 by Vt. Okay, so I am highlighting this one because this one is a very important relationship. Okay, so we have find because this I and this I will be same, and this I simple KVL V input this voltage input Vi minus 0 by 2, and this I the diode equation, from diode equation 0 minus the diode voltage 0 minus V0. Okay, so we can write this as a an equation. Now what we can write for Vi 2 volt, for Vi 2 volt, okay, Vi 2 volt, it should be, you have to select the pencil first. Okay, so we can write Vi when 2, so 2 by 2 equals to is exp minus p naught by vt. So it should be 1. So one can write this as a 1 by is. Okay, this should be clear. So I am just writing this as a 1 by is exp minus v naught 1 by vt, because here we are taking vi 2 volt, so we have put at the vi 2 volt, and v naught equals to v naught 1. Okay, this one, this thing we are using. Okay, so one can also write the same one as a, if we take ln on the both side, ln 1 by is we can write, and this one exp, so ln e to the power minus of v naught 1 by vt. Okay, we can write exponential as a e also, or we can write exp, what you want you can write. So it should be minus p naught 1 by vt. So from this one we can also write this as a ln 1 minus ln is minus v naught 1 by vt. So ln 1 value will be 0. So one can write v naught 1 equals to, this minus minus will be also cancelled. So vt log is. Okay, so this one is the important relationship by considering this one, vi equals to what, v naught 1. Okay, I am saying this one is equation number 2. Okay, this one is equation number 2. Now we have to consider the second case. This case is over now. Okay, now we have to take care of this second case. So for the second case, when vi equals to 4 volt, we are saying v naught equals to v naught 2. Okay, so we can directly use this expression, say this as a also 1, equation number 1. So we can write as vi by 2 equals to is exp minus p naught by vt. Okay, it is coming from here, this equation. Okay, now vi is 4 volt, vi is 4 volt, better to write 4 by 2 is exp v naught is now our v naught 2 divided by vt. This is a very simple question, only we have to do some calculation. So 4 by 2, 2. So one can write 2 by is exp minus p naught 2 by vt. Okay, so now again what we can write, if we take ln on both sides, ln 2 by is, then okay, once again I am writing e to the power minus p naught 2 by vt, which is our basically our minus p naught 2 by vt. So now one can also write this as a ln 2 minus ln is. Okay, just using ln a by b, ln a minus ln b. Okay, and this one minus v naught 2 by vt. Okay, and one more line we can write minus v naught 2 equals to vt times whole term ln 2 minus ln is. Now one can write v naught 1 is there, and also the value of v naught 2 is there. Okay, so now we have the four options. So which option uh, will be the most suitable, because root 2 term is not there, a square term is not there, so it will be also not a v naught 2 equals to v naught 1 into ln 2, not possible. Okay, so the fourth option, v naught 1 minus v naught 2. So v naught 1 is there and v naught 2 is there. So what we can write, we can write as v naught 1 minus V note 2. So V note 1 is Vt ln Is and V minus V note 2, that is our this one. So it should be plus Vt ln 2 minus Vt multiply ln Is. So this should be, and this we cancel out. So V naught 1 minus V naught 2 equals to Vt ln 2. So this one is the suitable relationship we can say. Okay. So this one is the suitable relationship that we have find out. So the correct answer for the above question is option number D. So this is the very simple question. So we have to just use the concept of diode equation given. So Is exp if Vd by Vt. So voltage across this diode 0 minus V naught. So that's why it is coming Is exp minus V naught by Vt. This one is the main equation we can say. Then we are doing for this one. Vi 2 volt, V naught equals to V naught 1. Then we have written the expression for V naught 1 as a function of Vt upon Is. Similarly, Vi equals to 4 volt, we can write this minus V2. So we can easily say the correct relationship will be V naught 1 minus V naught 2 equals to Vt ln 2. So this is the correct way to solve such type of numerical, which is based on the diode and op-amp based circuitry. So this is all about this question. So thank you for watching this video.